This is Mrs. Appia with Lesson 5 from Module 6, Identical Triangles. This is on page 30 in your book. Student outcomes for this lesson. Students use a triangle correspondence to recognize when two triangles match identically. Students use notation to denote a triangle correspondence and use the triangle correspondence to talk about corresponding angles and sides. Students are able to label equal angles and sides of triangles with multiple arcs or tick marks. Lesson notes. This lesson provides a basis for identifying two triangles as identical. To clearly define triangles as identical, students must understand that triangle correspondence is and be able to manipulate the relevant notation and terminology. Once this is understood, students have the means, specifically the language, to discuss what makes a triangle unique in Lesson 7 and forward. Pause the video and copy the essential question. How do you know if two triangles are identical? When studying triangles, it is essential to be able to communicate about the parts of a triangle without any confusion. The following terms are used to identify particular angles or sides: between, adjacent to, opposite to, and included. Adjacent means that two sides meet at a vertex. In exercises 1 through 7, we'll use the figure triangle ABC to fill in the following blanks, and we'll use the words between, adjacent, opposite, and included. Angle A is blank, sides AB and AC. So here is side AB and here is side AC. And the question is, how is angle C or angle A related? Angle A is between. Next, angle B. How is it related to side AB and side BC? Side AB is here, side BC is here, and the question is, how is angle B related? Is it between, adjacent, opposite, or included? Angle B is between. Next, how is side AB related to angle C? Side AB and angle C. Side AB, is it between, adjacent, opposite, or included? It is opposite. Side blank is the included side of angle B and angle C. So here we have angle B and angle C. And the question is asking, what is the included side? The included side would have both B and C as part of the segment, and so that will be this side, BC. Notice how both of the vertices B and C are included in the side name BC. Next, what is opposite to side AC? Here is side AC. Opposite to AC is angle B. Number 6. Side AB is between what and what? Here is side AB. What is it between? It is between angle A and angle B. Number 7. What is the included angle of side AB and side BC? AB and BC. The included angle is not angle A, is not angle C, it is angle B. It is the included angle. Add number 8 to your paper. Side AB is blank to side BC. Side AB is here, side BC is here. And how are they related? Side AB is adjacent to side BC. Recall that the definition of adjacent to, two sides that meet at a vertex. So they are sides that meet at vertex B. So the two sides are adjacent to each other. When you are identifying relationships between sides and angles, it's often helpful to either draw and relabel the triangle several times so that you can highlight, or you could lay toothpicks down on the sides to look at the relationship. Now that we know what to call the parts within a triangle, we consider how to discuss the two triangles. We need to compare the two parts of the triangles in a way that is easy to understand. To establish some alignment between the triangles, the vertices of the two triangles are paired up. This is called a correspondence. The vertices of two triangles are paired up. The paired up is called the correspondence. Specifically, a correspondence between two triangles is a pairing of each vertex of one triangle with one and only one vertex of the other triangle. A correspondence provides a systematic way to compare parts of two triangles. In Figure 1, we can choose to assign a correspondence so that A matches to X, B matches to Y, and C matches to Z. We notate this correspondence with double arrows. A corresponds to X, B corresponds to Y, and C corresponds to Z. This is just one of the 6 possible correspondences between the two triangles. 4 of the 6 correspondences are listed below. Find the remaining 2 correspondences. Why do we take time to set up a correspondence? A correspondence provides a systematic way to compare parts of two triangles. Without a correspondence, it would be a bit difficult to discuss the parts of a triangle because we wouldn't have no way of referring to the particular sides, angles, or vertices. How is it possible for any two triangles to have a total of 6 correspondences? We can match the first vertex with any of the 3 vertices. Then, the second vertex can be matched with any of the remaining 2 vertices. You'll want to read through this part again and memorize it. The vertices of two triangles are paired up. That is called a correspondence. And specifically, a correspondence between two triangles is a pairing of each vertex of one triangle with one and only one vertex of the other triangle. As we pair up these triangles, I want you to notice that when the correspondence is assigned, just because the 2 vertices correspond to each other in this case does not mean that they are the same. All right, so we have angle A corresponds with angle X. So here is angle A and here is angle X. Notice that they are just on the lower left-hand corner of the triangles. Next, we have B corresponding with Y. Here is angle B and here is angle Y, and those are both on the top of the triangle. And as I said before, just because they're corresponding in this case doesn't mean that the angles have the same measure. Finally, angle C corresponds to angle Z. Here is angle C and here is angle Z. Notice that they do not have the same measure. They are in the same position, the lower right-hand corner. So that is just one of the correspondences. We could match them up in a different way. In the next figure, they have chosen to pair angle A with angle X. So here is angle A and here is angle X. Next, we have angle B paired with angle Z. So notice how the arrow is going down. Angle B corresponds to angle Z. Here is angle B and here is angle Z. So they are not in the same relative location on the triangle. Then the third one, we have angle C paired with angle Y. Here is angle C and here is angle Y. So that is a different setup than the first one, a different correspondence. In the next figure, we have another correspondence showing. You could pair angle A with angle Y. Here is angle A and here is angle Y. So in our first example, we had angle A paired with X. In our second figure, we have angle A paired with angle X. And in this pair, we have angle A paired with angle Y. Remember that there are 6 different correspondences that we can show. Next, we have angle B paired with angle X. Angle B is paired with angle X. Here is angle B and here is angle X. And finally, C corresponds to Z. C and Z. Notice how they are notating the correspondence. They are showing the notation with a double arrow between the 2 angles. In our next figure, we have angle A corresponding to angle Y. Angle A corresponding to angle Y. Notice the double arrow. Angle A and angle Y. In our second correspondence, we have angle B with angle Z. And in our third correspondence, angle C corresponds to angle X. Those are 4 of the correspondences. We know that there are 2 more correspondences, so we're going to find those next. So let's go ahead and write down A, B, C. Those are the vertices on the first triangle. And then the vertices on the second triangle are X, Y, and Z. Now we already have A paired with X. We already have A paired with X again. And for our next one, we'll have A paired with Z. So let's highlight that. We have A paired with Z, A paired with Z. Whoops, let's change that. Now you might be thinking, how did you know to pair A with Z? In our first figure, we have A paired with X, and our second, A paired with X. In our third figure, we have A paired with Y and A paired with Y. So we also need to pair A with Z twice. So here we have A paired with Z. I'll go back and show the correct notation with a double arrow when I'm completed this. Next we'll do angle B. And angle B corresponds to, well, let's see, we already have it paired with Y in this one. And we already have it paired with X, and we already have it paired with Z twice. So we're going to need to compare to correspond it to Y and to X. So here, let's do it with Y. So B corresponds with Y, and then that leaves us with C and X. And again, I'll go back afterwards with my double arrows. Then let's write our ABC again, and our X, Y, Z. And we know that we need to correspond A with Z one more time. And we need to correspond B with X so that it is corresponding twice. And that leaves us with C and Y. So we have C and Y corresponding to each other. Then we have B and X corresponding to each other. Let's make sure that these are color-coded correctly, B and X. And then finally, we have A and Z. So now I'm going to go ahead and show the correct notation. The correct notation is going to have an arrow at both ends. So we have A corresponding to Z, and Z corresponding to A. B corresponds to Y, Y corresponds to B. C corresponds to X, X corresponds to C. A and Z correspond, so we put an arrow at both ends. B and X, and C, Y. The reason we put an arrow at both ends is to show that C corresponds to Y and Y corresponds to C. So again, what is the purpose of showing these correspondences? It's a systematic way of talking about triangles so that you know which sides you're talking about and which angles you're talking about. Before we continue on this page, I'd like you to redraw triangle ABC and triangle XYZ. A simpler way to indicate the triangle correspondence is to let the order of the vertices define the correspondence. That is to say, the first corresponds to the first, the second corresponds to the second, and the third corresponds to the third. The correspondence above, using each vertex individually, as on the previous page, can be written in this manner. Write the remaining two correspondences in this way. So let's talk about what it means by the first and the first. Here it says triangle ABC corresponds to triangle XYZ. And what that means is that the first vertice A corresponds to the first vertice X. Here is A and here is X, and those are corresponding because they're in the first position. The second letter, B, corresponds to the second letter, Y. So we have the angle B corresponding to angle Y. And then the third letter, C, corresponds to the third letter, Z. Angle C corresponds to angle Z. So this is an easier way to show correspondence. You just write the letters and then put them in the order that you want the corresponding sides. All right, let's go over the next one. We have triangle ABC corresponding to angle XZY. Notice that they have changed the order of the angles. So here we have the first letter A corresponding, there's the first letter A corresponding to the first letter X. So those are our corresponding angles. Then the next one would be angle B corresponding to angle Z. So we have angle B and angle Z. Next, we have triangle ABC corresponding to triangle YXZ. Notice again that this is a different order for the second triangle. So we have angle A corresponding to the first angle, which is Y, angle A and angle Y. Then we have the second letter corresponding to the second letter. So we have the angle B corresponding to angle X. And in our next example, triangle ABC corresponds to triangle YZX. So we have the first letter A corresponding to the first letter Y. So here is A and here is Y. Then we have the second letter corresponding to the second letter. So we have B corresponding to Z. And then the third letter, C, corresponds to X. So we have angle C corresponding to angle X. Now, there are two more correspondences. So pause the video and see if you can figure those out. So here's a clue. You're going to start out with triangle ABC and your double arrow to show the correspondence. Triangle ABC and then the double arrow showing the correspondence. So what you need to figure out is the order of the three letters for the second triangle. Another clue. Notice that you have X first and X first, and Y first and Y first. So here you would have to have Z first and Z first. Pause the video and try to finish the problem. You haven't used the letters X and Y yet. So here you would use XY, and here you will use YX. And those are the 6 correspondences for those triangles. With the correspondence in place, comparisons can be made about corresponding sides and corresponding angles. The following are corresponding vertices, angles, and sides for the triangle correspondence of triangle ABC corresponding to triangle YXZ. Complete the missing correspondences. Before we do that, let's go over the terms to make sure that we're on the same page. The vertices are where two sides meet. So this is vertex A, this is vertex B, and this is vertex C. Angles. Angles include the sides. So this is angle A, this is angle B, and this is angle C. The sides include the segments between the angles. So this is side AB, side AC, and side BC. Notice that I've scrolled so that we don't see the triangles anymore. If you have the triangle correspondence given to you, then you don't actually need to see a picture of it. So you just use the order of the letters. So taking a look at our first one, it says that our first letter of A corresponds to our first letter of Y, and that's right here. So then the other correspondences would be B corresponds to, go ahead and write that down, and then C corresponds to, go ahead and write that one down. Then the angles. Angle A, so we want to use the order. Angle A is the first angle, and it corresponds to angle Y, which is the first. So then angle B would correspond to what other angle? And angle C corresponds to what other angle? Next, taking a look at the sides. We have side AB. So side AB, that's the first two letters. So that's going to correspond with the first two letters of the second triangle, which is YX. Now, let's take a look at the others that you're going to fill in. We have side BC, which is the second and third letter. So what will it correspond to? And then side CA. CA will correspond to what other side? Make sure that you fill those in, pause the video, and then check your answers. B corresponds to X. They are both the second letters. C is the third letter, so it corresponds to Z, the third letter. Angle B is the second angle, so it corresponds to the second angle, angle X. Angle C is the third angle, so it corresponds to the third angle, which is Z. BC corresponds to YX. and CA corresponds to ZY. Example 1. Given triangle ABC and triangle STR, fill in the correspondences. Okay, so first we'll do the correspondence of the vertices. Remember that a vertex is where two sides come together on a polygon. So we have vertex A corresponding with, so that's the first letter and the first letter, and that will be S. B corresponds to T, and C corresponds to R. Next is correspondence of angles. We have angle A, and it's the first angle, and it will correspond to the first angle, S. Angle B corresponds to T, and angle C corresponds to R. Correspondence of sides. AB, first two letters, that's right here, and that's corresponding to the first two letters, ST. Correspondence of BC corresponds to TR. BC corresponds to TR. And CA corresponds to RS. Okay, CA and RS. Examine figure 2. So figure 2 is the top figure on this page. Simply by looking, it is impossible to tell the two triangles apart unless they are labeled. They look exactly the same, just as identical twins look the same. One triangle could be picked up and placed on top of the other. Two triangles are identical if there is a triangle correspondence so that corresponding sides and angles of each triangle is equal in measurement. That's an important concept. Two triangles are identical if there is a triangle correspondence so that the corresponding sides and angles of each triangle is equal in measurement. So I think our opening question was, how do you tell if two triangles are identical? Well, you match up the corresponding sides and angles, and if the sides are equal in measure and the angles are equal in measure, then the triangles are identical. In figure 2, there is a correspondence that will match up equal sides and equal angles, so that triangle ABC, so here we have triangle ABC, corresponds to triangle XYZ. We conclude that triangle ABC is identical to triangle XYZ. This is not to say that we cannot find a correspondence in figure 2 so that unequal sides and unequal angles are matched up, but there is a one correspondence that will match up angles with equal measurements and sides of equal lengths, making the triangles identical. Let's read through that one more time. It's important. There is one correspondence that will match up angles with equal measurements and sides of equal lengths, making the triangles identical. In discussing identical triangles, it is useful to have a way to indicate those sides and angles that are equal. We mark sides with tick marks and angles with arcs if we want to draw attention to them. If two angles or two sides have the same number of marks, then they are equal. In this figure, side length AC is congruent to side length DE, which is congruent to side EF. So let's take a look at that and what those marks are. We mark sides with tick marks. So here is side AC, right here, and then we have side DE, which is right here. Notice that they're not in the same location. and that is also the same measurement as EF, and EF is right here. So the tick marks that they are talking about are right here. There are two tick marks, and two tick marks. And that means that this side length is the same as this side length, which is the same as this side length. It also says that angle B is congruent or equal to the measure of angle E. So we have angle B right here, and it's labeled with an arc, and it is the same measure as angle E, which shows one arc. So one arc in each angle shows that they are equal in measure. Example 2. Two identical triangles are shown below. Give a triangle correspondence that matches equal sides and equal angles. So you want to look at the arcs for the angles. We have angle A having one arc, so we'll have A first, and then the other triangle has one arc in angle T, so that will be our first letter. Then let's look for the one with two arcs. So we have angle C with two arcs, so that will be our next letter. And in the other triangle, the angle that has two arcs is R. So C and R are corresponding. Then, going back, we have three arcs paired up with three arcs, so they are corresponding. So we have B and S. So these are triangles, so we're going to label that with a triangle in front of the letter to show that that is triangle ACB and triangle TRS. And then remember that the notation to show correspondence is a double arrow. Then you think, does the order matter? Well, you could write them in this order as well. If you wanted to, you could write triangle ABC so that you had them in the alphabetical order A, B, C. Then if you change the order of the first triangle, you also need to change the order of the second triangle so that the first letter matches up with the right angle. So A corresponds to T, so that would be our first letter. B corresponds to, now again, that's the third letter, so that would correspond to S. And then C corresponds to the middle letter, which is R. So if you change the order, make sure that you're careful about writing it correctly. And then I'm just going to double check. A has one tick mark and T has one tick mark. And then the second letter B has three tick marks, and the second letter S has three tick marks. Okay, so I know that that is correct. All right. The order of the letters does matter because the angles correspond to each other, so be careful about that. Just to double check, can you define what triangle correspondence is? If not, go back to page 31 and copy the definition and practice it. Exercise 8 says, sketch two triangles that have a correspondence. Describe the correspondence in symbols or words. Have a partner check your work. So when you draw your two triangles, I would draw one of them a little bit bigger than the other and use letters, and then you want to write down your correspondence using a triangle, and then the order of the letter matters. Remember to show correspondence with the correct notation, and that would have a double arrow. Pause the video and complete this activity. You'll check this work with your table mate tomorrow in class. When you're done with that activity, resume the video and complete the summary. Two triangles and their respective parts can be compared once a correspondence has been assigned to the two triangles. Once a correspondence is selected, corresponding sides and corresponding angles can also be determined. Double arrows notate corresponding vertices. Triangle correspondence can also be notated with double arrows. Triangles are identical if there is a correspondence so that corresponding sides and corresponding angles are equal. An equal number of tick marks on two different sides indicate the sides are equal in measurement. An equal number of arcs in two different angles indicate the angles are equal in measurement.